Alright, y'all. Test tomorrow, 3.1 review. This is for Algebra 2L. Square root and inverses. Okay, so let's start with number 1. So we're looking for, it says find the inverse of the following functions, show all work. So let me get this all set up for me. Okay, so first things first, g of x just means y. So this is like saying y equals x minus 3 over 2. So remember, to do the inverse, x and y switch. So it's going to be x equals y minus 3 over 2. So first things first, we need to get rid of the 2. So we're going to multiply both sides by 2 because the opposite of dividing is multiplying. Okay, that cancels those. So no, don't multiply, okay? Not on, well, you multiplied, but don't distribute it or anything. So 2x equals y minus 3. So we're trying to get y by itself, so we need to get rid of the minus 3. Okay, sorry. So we're going to add 3 to both sides. So we end up getting y equals 2x plus 3. Okay. So then we have number 2. So again, same thing as y. So we have x, we flip them, 2y minus 6. Add 6 to both sides. And I get x plus 6 equals 2y. Okay, we're still trying to get y by itself, so we need to divide, because that's the same thing as multiplying. Divide by 2, divide by 2. Now, typically we could leave this, but we're not going to here because 6 and 2 will simplify. So I'm going to kind of bring this over here. So y equals, so remember this is the same thing as separating, and this is the same thing as 1. So 1 over 2x plus 6 over 2, which is the same thing as 3. So y equals 1 over 2x plus 3. Okay, h of x is the same thing as saying y. So x equals y squared minus 7. So we're trying to get y by itself, so we're going to add 7 to both sides. And I get x plus 7 equals y squared. So I have to take the square root to cancel the squared, because that's the opposite. That cancels that. Get y equals square root of x plus 7. Okay, number 4. Again, same thing as saying y. So x equals square root of y plus 1. So since it's taking the square root of everything, we have to get rid of the square root first. The opposite of square root is squared. What I do to one side, I have to do to the other. The square root cancels the squared, and I get x squared equals y plus 1. So now I need to get rid of that plus 1, so we're going to subtract 1 from both sides, and we get y equals x squared minus 1. Okay, so again, same thing as y, so we get x equals y plus 5 over 2. Multiply both sides by 2. This cancels, and we get 2x equals y plus 5. So we have to get y by itself, so we're going to subtract 5 from both sides. And I get y equals 2x minus 5. Last but not least, for these, y equals, x, remember this is y, so x equals 3y minus 6, 9, I don't know why I said 6, sorry. So I'm going to add 9 to both sides. This cancels, and I get x plus 9 equals 3y. So I have to get rid of that 3. They're touching, which means multiply, so divide. Now, 9 divided by 3 simplifies. So again, we have to separate like we did here. So remember, this is the same thing as 1x. So 1x over 3 plus 9 over 3 equals y, which is the same thing as saying, I'm going to flip my y over here. 1/3 x plus 9 divided by 3 is 3. Cool. If you have any questions on those, other than what I just said, and this isn't clicking, bring it to me tomorrow. But you come to class way before the bell rings, as soon as you can, and I'll answer your questions. Okay, so it says, do you have to restrict the domain of any of the functions above? So remember, we restrict domains when we go from a shape to a different shape. So like here, the square root looks like this, while a quadratic looks like this. So that we have to restrict the domain because we're going to turn this into a half of a u. Okay, so here though, this is linear and this is linear. Well, that doesn't change anything, so we didn't have to restrict anything. So we're only restricting the ones like this that go from square root to squared. So number 3. Oh, so do you have to restrict any of the domains above? So the answer is yes. And we're going to do number 3 and number 4. Because, how do we know which to restrict? It's when we have square root versus quadratics, or squared. Okay, because the square root looks like this, while a quadratic looks like this. So this is like half of a u, and that's a whole u. So we have to make them match when we're doing inverses. Okay. So find the inverse of the following, then graph both of the functions and its inverse on the same grid. Make sure to graph the line of reflection. And to label clearly what is what. So the graph of h of negative 1x, the inverse of x, h of x, is the graph of h of x reflected over y equals x. Guys, this is a test question, and it's not multiple choice. You have to know this. Okay? So let's go ahead on all of our papers. I'm going to use a different color. And let's graph the y equals x. I'm just going to use a pencil. Okay, remember how to plot it? I told y'all, put a point at negative 10, negative 10, 0, 0, and 10, 10, and use your ID badge. Look, I have a student's ID in here. There we go. 10, 10, 0, 0, negative 10, negative 10. And then same here. Okay, so that's my y equals x. This is my reflection line. Okay. So first things first, I'm going to use my purple and I'm going to plot the lines that are given to me. Guys, use your calculator. There's no reason not to. So I'm going to come here, I'm going to type in my equation. So 2x plus 5, second graph, and I'm going to find my pretty points. So negative 5, negative 5. So I'm going to start here. Negative 7, negative 9. Negative 7, negative 9. Negative 6, negative 7, negative 6, negative 7, negative 5, negative 5. So if you notice, it's going up 2 over 1, up 2 over 1, because this is a linear line. You can even check your points. So we should have a point 0, 5, which I do. Negative 1, 3, which I do. Okay, so on and so forth. So there's my first line. This is my g of x, my original. Okay. So my inverse, sorry, I'm looking for my colors. I'm going to do this color if we can see it right. Okay, so this is the same thing as saying y. Yeah, you can see that. Okay. X equals 2y plus 5. So subtract 5 from both sides. Bring it over here. X minus 5 equals 2y. Divide both sides by 2. And I'm done. Okay. So it's x minus 5 over 2. Now, use your calculator. Alpha y equals enter. Gives us our fraction. X minus 5 over 2. Second graph. So negative 9, negative 7, negative 9, negative 7, negative 7, negative 6, negative 5, negative 5. So it's going up 1 over 2, up 1 over 2. So this is my inverse. Okay, and then think about it. If I turn it this way, because it's reflecting over that line, okay, does it reflect perfectly? Yes. Yes, it does. Okay, so let's try number 10. So x squared plus 1. Oop, I forgot to put 1. Remember, when you're graphing a quadratic, you're finding your rainbow. There we go. So negative 310. I'm going to move this over here so I can write negative 310. Negative 25. Negative 1, 2. So this is my h of x. So now let's find our inverse. Okay, so this is the same thing as saying y, so x equals y squared plus 1. We're going to minus 1 on both sides. Bring it up here. We get x minus 1 equals y squared. How do we cancel a square? The opposite is square root. Square root cancels the squared, and I get y equals square root of x minus 1. So remember, we scroll till we don't see error. So 1, 0. So this one's a good one to talk about. So it says find the domain of the inverse. So that's this one. Domain is your width. Okay, so that's 1 to infinity. Now I want to know, do we restrict this one? So my answer is yes. We restrict the quadratic domain. Okay, and to be a perfect reflection, it's going to be the range of the square root. So from 0 to infinity. 0 to infinity would be this. Is that piece and that piece a perfect reflection? Yes. So restricted domain of quadratic is from 0 to infinity. Remember, it's the range of the square root graph. Range of the square root graph, okay? So let's try number 11. Let's graph the original. Find our error, there it is. So negative 1, 5, 0, 6, 3, 7, 8, 8. So that's my m of x. So to find my inverse, I'll say x equals square root of y plus 1 minus 5, or plus 5, sorry. So to get rid of the plus 5 first, because it's on the outside, we'll subtract 5 from both sides, and I get, x minus 5 equals square root of y plus 1. So then I have to square both sides to get rid of the square root, and I get x minus 5 squared equals y plus 1. So I'm going to subtract 1 from both sides, and now my y is by itself. So x minus 5 squared minus 1. Okay. There's my rainbow. So 2, 8. 3, 3, 3, 4, 0, -1, 6, 0, so here the domain of the inverse is negative infinity to infinity. What would the restricted domain be? So remember, it's going to be the range of this, so this goes lowest is 5 and goes up forever. So 5 to infinity. We'll look, I'm going to circle it with this color. From 5 to infinity would be this side, and that is the perfect reflection, so that is correct. So this is kind of good, like the first, like number 7, it was talking about like graphs like this versus this. So here we didn't have to restrict because it's a linear and linear. So like number 1, number 2, number 5, and number 6 were all linear. So they'd be like this. There's no restricting anything. But number 3 and number 4 were like this, so we would have to restrict them. Okay, let's look to the back of this page. Okay, I'm going to kind of take this one piece at a time. So is the original a function? Yes. So let's build a table for the original. So 1, 2, 3, 4. Negative 4, 0. Negative 3, 2. Negative 2, negative 2. Negative 2, 1, 2, 3, 4, 5. Negative 1, 3. And 3, 1. So my inverse would be that opposite. So 0, negative 4, 2, negative 3, negative 2, negative 2, 5, negative 2, 3, negative 1, and 1, 3. So let's plot those points. So 0, negative 4, 1, 2, 3, 4. 2, negative 3, 2, negative 2, negative 2, which is this point. 5, negative 2, 1, 2, 3, 3, negative 1, and 1, 3. So there's my inverse. Now is the inverse a function? Well, does x repeat? It does not, so inverse. Oh wait, hold on. Sorry, the original is not a function. My bad, I caught my mistake at least. The original is not a function. See how crazy I am with whiteout. The original is not a function because x repeats right here. So it's not a function. Sorry about that. Is the original function? No. Okay. My bad. So this one, the original is a function if I did the vertical line test. Here if you look, see when I do the vertical line test it touches twice? That's why that's not a function. Okay. This one, if I do the vertical line test everywhere, it's still a function. Okay, so this is a function. So I'm just going to make a table of a couple points. So here's a pretty point, here's a pretty point. So this is 1, 2, 3, 4, negative 3. Oh, sorry, negative 4, negative 3. Negative 2, 0. 0, 3. And 2, 6. So the inverse it'll be -3, -4, 0, -2, 3, 0, 6, 2. I just flipped my x and my y just like I did here. Okay, and I'm going to plot those points. -3, -4, 1, 2, 3, 4. 0, -2, 3, 0. So is this one a function? Yes, this is also a function. Okay, last but not least, this is a lot of points, so I'm going to write kind of small. So first off, this is a function because if I draw a vertical line anywhere, it will never touch more than once. So it passes, yes, it passes the vertical line test. So -5, 2, -4, -2, -3, 2, -2, -2, -1, 2, 2, -2, 3, 2, and 4, -2. So let's build the inverse. Two, -5, 0, -2. I also want you to realize these last 3 points are going to be that little one by itself. So I'm just going to draw a line there so I know. -3, so 2, -3. Oh man, I'm looking at the wrong graph. Sorry, -2, -4. I'm throwing myself off of this orange graph. -3, 2, -2, -2, 2, -1. So there's my first piece. Then -2, 2, 2, 3, and -2, 4. So I'm going to do this little piece first. -2, 2, 2, 1, 2, 3. -2, 1, 2, 3, 4. So there's that first little piece. That's the reflection of that. Okay, and then 2, -5. -4, -2. Wait. I didn't flip that. My bad. That should be -2, -4. -2, -4. 2, -3. -2, -2. Okay. There's my inverse. Now, is this one an inverse or a function? No, if I draw a vertical line there, it touches a bunch of times, so it's not a function. Okay. Ooh, sorry, that one was a lot, and I messed up a couple times. See, I'm a real person, promise. Okay, so it says the table represents a few points from a function m of x. Find the range of the inverse. Okay, so let's find the inverse. I'm going to build the inverse table over here. -9, -12, -7, -9, -5, -6, -3, -3. So since this is just a couple points, I'm going to say this is discrete because we don't know what kind of graph this is or if this goes on forever. So it's a list of my range. Okay, so -12, -9, -6, -3, -12, -9. There's my answer. Now, could you have also realized that the inverse range is the same as the domain of the function? Remember opposites? Okay. Here, the function p of x equals 2x minus 5, and mx is this. Are they inverses of each other? Prove using composition. So I'm just going to prove algebraically. This is y, so I'm going to have x equals 2y minus 5 plus 5 plus 5. X plus 5 equals 2y divided by 2 divided by 2. Yes, that matches. So yes. They are inverses. All right. Y equals square root of x. Then write the equation that each statement represents. So translate right 2 is going to be, that's an IHOD change. So right 2 is on the inside and down 5 is on the outside. Y equals square root of x. Right 2 is going to be plus 2 because it's opposite, and outside is exact, so minus 5. Guys, check these in your calculator. There's no reason not to check these in your calculator. So I'll check one, but I'm not going to check all of mine. X plus 2 minus 5, second graph. Oops, sorry, graph. So did that go? Nope, I went left 2. See, I even made a mistake. I'm thinking left instead of right. Down 5. I even said opposite. So this should be minus. Sorry, y'all. I'm sleep deprived today, but I'm trying. That's what counts. So it's minus 2. Okay? Sorry about that. Okay, I won't mess up again, I promise. Actually, I don't. I might. Okay, reflection over the y-axis. So I always like to draw a picture to remind myself. Reflection over the y, okay, is a side-to-side change, which is IHOD. So IHOD over, I'm making a mess, over, okay, so IHOD is an inside horizontal change, okay, so reflection over the y-axis, and reflection means negative, and translate left 6, so left 6 is also an inside change, so y equals square root negative x, and left 6, so remember, left is plus, while right is positive because it's opposite, so plus 6. I got that one right this time. Okay, translation up 7 and vertical expansion by 3. Well, vertical is outside, so y equals 3 on the outside, square root of x, and then up 7 is also on the outside, so it's going to be outside plus 7. So now I'm given a graph and I'm told to describe it. So the 2 on the outside means a vertical expansion because it's bigger than 1 by 2. Okay, the negative on the inside, we just did that, is reflect over the y-axis. And the minus 3, minus means right. So, and right 3. So again, check your work in your calculator. 2 square root negative x minus 3. So at right 3, it's an expansion and it reflected over the x. So this is correct. So let's graph this. So I'm just going to use the rules, but you can always use a calculator like we have for all the other graphs. Okay, so square root of x minus 4. So minus 4 on the outside means down 4. Okay, so domain is my width. Well, range is my height. So width, it starts at 0 and it goes to the right forever. So from 0 to infinity. Now my height, it starts at negative 4 and it goes up forever. So negative 4 to infinity. Because remember, you go left, right, from left to right, and here you go from bottom to top. Okay, because that's how we do it. Okay, so here I'm gonna graph this one just so I'm careful instead of trying to multiply in my head. 3 square root x plus 1, second graph. Find my error, there it is. So negative 1, 0, 0, 3, 3, 6, 8, 9. Okay, so farthest left is -1, and it goes right forever. Lowest is 0, and it goes up forever. Okay, write an example of a radical function where the domain is x is greater than 3 and range is y is greater than or equal to -5. So I like to draw pictures. Here's 3. If it's greater, it's going to the right. And y is -5, so we'll say this is -5, and it's greater. Y is greater, so it's going up. So this is where it starts, and it's go up and right. So it doesn't say anything about expansion or compression, so we're not going to worry about that. We're just going to talk about the shifts left and down, or right and down, sorry. So y equals, right is an inside change, and to the right we'll subtract because it's opposite. So x minus 3, and then minus 5 on the outside. I want you to really see how this is the opposite, because x is always opposite, and the y is exact. The outside is the exact. Okay, write an example of a radical function where the domain is x is greater than 1, and y is greater than 8. So here, so greater is up and over. So y equals x minus 1 and then plus 8. And again, you could check these in your calculator. Type that in and check it. Guys, a lot of this test can be checked or done in your calculator. So this is a really simple test to be getting an A or a B on. The square root parent function is y equals square root of x, has a domain, so this is it, so domain is from 0 to infinity, and range from 0 to infinity. What is the inverse of y equals x? Well, the inverse, the opposite of y equals x is y equals x squared. What is the domain of the inverse? So I want you to remember that the y equals x squared looks like this, and it goes from negative infinity to infinity. But if we restrict the domain to match, it would be the range of the square root. So it would be 0 to infinity. Okay. 26, 27, or 26, A, B, and C, sorry. Okay, so we're going from the solid line because that's the parent function. And we're finding the equation for the skinnier line. So this one went up 1, 2, 3, 4, 5. So we shifted up 5. It did not shift left or right, and there's no change, and we know that because up 1 over 1. There's no compression or expansion. So we literally just went up 5. So y equals square root of x. Up is on an outside change, so plus 5. Here we went down 1, 2, 3, 4. So we went down 4. But again, up 1 over 1, so there's no other change. So y equals square root of x minus 4. Here, if you notice, they both start at 0, 0, so there's no up, down, left, or right. But it's taller. It's expanded height-wise. It goes up 1, 2 over 1. So it's got a vertical expansion of 2. So 2 square root of x. 2 over 1, 2, same thing. Okay. Again, could you check these in your calculator? Absolutely, you could. So I'll show you how to check one in your calculator. We'll do number A, my beautiful English. So the first one is a parent function. And we said a square root of x. Oop, not on the inside. Outside plus 5. So there's my original, which looks the same, and there's my new. So this matches, therefore I'm correct. Okay, that's how you'll check those. The function y1 equals square root of x minus 4 is translated 7 units up to form y2. So I want you to realize something. Square root of x minus 4. This graph is telling me the parent function went down 4. So negative 3, negative 2.6, I'm rounding, negative 2.3, negative 2, negative 1.8, and negative 1.6. Okay, if I went 7 units above that, that's adding 7 on the outside. Well, negative 4 plus Negative 4 plus 7 is 3, so adding 3. So square root x plus 3, second graph. Well, negative 3 plus 7 is 4, so that's right. Okay, all of these, if I added 4 or added 7, would give me this answer. This plus 7 gives me that, plus 7 gives me that. Okay, and so on and so forth. 4.7, 5, 5.2, 5.4. Find the inverse for the following representations. So my inverse, I'm literally just going to switch my x and my y. So 6, comma 1, 2, comma 2, which kind of stays the same, negative 2, comma 3, and negative 6, comma 4. Again, just switching my x and my y. So 0, 1, 2, 3, my y's become my x's, and my x's become my y's. Negative 3, 2, 7, 12. Simple as that. Last page. This is a long one. Which square root function is represented by the table shown at the right? Okay, so guys, calculator. There's no point not to use your calculator here. So square root of x minus 2, second graph, start at negative 2, because that's where this one starts, or we'll even go negative 3. This is a bunch of errors, so that's not my answer. So let's try negative square root of x plus 2. So it says error 0, 1, 1.4, 142, 1. So this matches. So my answer is B. And you can even check the other ones just to be safe. Not right. And not right. So there's my answer. In order for the function of y equals x and y equals x squared to be inverses of each other, which of the following must occur? So the domain, remember, we're always changing the quadratic. So the domain of this must be restricted. We never restrict the square root. So C and D are wrong. Okay. This is positive. These are all positive, so we just shouldn't have a negative. So it's going to be A. Okay. Because I'm going to sketch this. This is the square root of x squared. Remember, it's the square root of x, sorry. The range is 0 to infinity. So 0 to infinity. Remember, it's the range of square root, if I can spell, becomes restricted domain of quadratic. I know that's a lot, but I want you to see it in words. The range of the square root becomes the restricted domain of the quadratic. Here is the original function, a graph of function. Well, yeah, because I can draw a vertical line and it'll never repeat. My domain is from negative 10 to 10. And my range is from negative 10 to 10. Remember, I'm looking at lowest point to highest point, not like one point to the other. Okay, lowest point to highest point, farthest left to farthest right. Is the inverse a function? So let's graph it. So my graph for the original is negative 10, 2, 6, 10, and 10, negative 10. So my inverse would be 2, negative 10, 10, 6, negative 10, 10. So 2, negative 10, 10, 6, and negative 10, 10. So this is not, because if I draw a vertical line right here, it's going to touch twice, therefore this is not a function. But my domain is just the range. My range is just the domain of the original. Okay. M of x is this. Is this a function, yes or no? Well, x, negative 2, 8, 11, 8. 8 repeats, so this is not a function. My domain is negative 2, 8, 11, 8. And my range is 4, negative 16, 6, 6. Now the inverse would be flipping all that. So 4, negative 2, negative 16, comma 8, 6, comma 11, and 6, comma 8. So my range becomes my domain. My range was my domain. Is this a function? Again, 6 repeats now, so no. Last but not least, consider the equation of a function y equals 4x minus 7. Which of the following represents the inverse of the function? So I'm going to switch my x and my y. Add 7 to both sides. X plus 7 equals 4y. Divide both sides by 4. Now, that doesn't simplify, so I can leave it. But none of them look exactly like that. So again, I can separate 1x over 4 plus 7 over 4 and see which one matches. So I know they both should be over 4, and this doesn't have that, and that doesn't have that. And I should be adding, so D has to be my answer. Alright guys, test tomorrow. If y'all have any questions, bring them to me before class starts. Y'all are going to do great.